Okay. So homework assignment for today was continuing to practice with methods, right? So you should have been able to use what we updated from our previous project, the soccer team thing, moving things into procedures, and that should have directly helped you here in terms of organizing the code, right? And then from there, it was a lot more practice with manipulating strings and searching through strings and things like that. So questions that were fairly prevalent in going through this were um, kind of uh, dealing with the difference between strings and arrays. So tell me, let's go ahead and get our presentation open here. If you were to describe what an array is versus what a string is, what are the similarities? What are the differences? Go ahead. Okay. So like arrays have a bucket 0, bucket 1, bucket 2, and strings don't? You actually do know they do. What does the char at method do for strings? If I have a string called s and I say s dot char at 3, what's that doing? At the third bucket, the third index in the string, right? So strings are organized, indexed just like arrays. So if you have an array with 5 elements in it, you have a string with 5 elements in it, you have char at 0 in the string. Now the array, you don't use the char at method, you use the square bracket syntax for getting at that index, right? But they're organized the exact same way, all right? So what else can you tell me about arrays and strings? What's the difference between them? What limitation do strings have that arrays do not? It's that important limitation that you really could actually give me two answers to that. One of them we talked about quite a bit last couple classes. When I say that something is passed by reference versus passed by, or passed by address versus passed by value, what do I mean? They're contiguous or not? No. So if I have a method that I'm calling and something is passed to that method by address versus passed by value, what's the difference? Go ahead.
When you pacify value, you're giving a copy of that, whereas when you give address, you are passing actual things, so you're going to have side effects.
Okay, so it dealt with that argument between side effect versus non-side effect, right? So if we have a procedure and we pass an array to that procedure, arrays are passed by address. So the memory address of where that array can be found in memory is passed in. So any changes we make to that array inside of the procedure, inside of the method, would have permanent impact, would have side effects. So other parts of the program that were to look at that array after the method manipulated it would see those changes that the method made. As opposed to passing something by value, which all of our primitive types are, our primitive types, integers, chars, all those guys, as well as strings. So in that case, strings are treated like primitives, even though they're objects. They're passed by value to a method. And passing by value means, as he pointed out, a copy. So we're making a copy of the thing, we're passing it in, and anything that we do to manipulate that has no side effect. Those changes live and die with the scope of that method. And after that method's done, the old value of that parameter you passed in goes back to where is what persists. That makes sense? So that's passed by value versus passed by address. So an argument you can make is a difference between strings and arrays is that when we pass a string to a method, it's passed by value because, and this is an important concept here, because Java treats strings as a special case, all right? They treat them more like primitives than they do like objects, even though they are objects. every other object that you would pass to a method would be passed by address or passed by reference. So string is the one outlier there, okay? So we could say a difference between arrays and strings with that in mind is that arrays are passed to methods by address, strings are passed to methods by value. Therefore, if we change the contents of an array inside of a method, that change has side effect. It's a permanent change. If we change the contents of a string inside of a method in which it was passed to which it was passed, close enough, that has no side effect. Those changes are temporary inside of that procedure, inside of the method, and then we go back to the old value. All right, so that's one difference. Not the one I was fishing for, but so that will take that one off the table. So what's a final difference? An important difference for this homework assignment between arrays and strings. I'll even throw out another difference. Also not the one I'm fishing for. Strings are always collections of chars, right? Indexed collections of chars. If I have the string hello, I have 5 chars. And they are stored, as you point out, contiguous memory. Okay? Index 0, 1, 2, 3. Because more than likely, under the hood, strings are implemented in terms of character arrays. It's probably how they're written. So strings are always collections of chars, where arrays can be collections of anything that we can create a variable, of which we can create a variable. I'm on dangling preposition mode today. Good thing I'm a computer scientist. I wouldn't have gotten my dissertation written if it wasn't for my wife to fix all my grammar. They would have just assumed a 5-year-old wrote it. All the words sounded legit. When in doubt, add more commas, right? Just like the curly braces for programming. Compilers love that. All right, so what was I just talking about? Oh, arrays can be collections of anything, right? We can have a collection of integers. We can have a collection of chars, a collection of booleans, collection of strings, a collection of, we started talking about objects at the end of class last time. So we have a collection of players, something that we're about to invent, right? Okay, so arrays are more flexible with that in mind, but with that trade-off, by having that flexibility, we've kind of lost some of the special stuff built into strings. Strings have a lot of magic tricks that come with them, right? You know, all those methods that were introduced by the book, and then if you look at the documentation, and we'll delve into the documentation a little bit today, you know, there's a lot of magic tricks, a lot of extra features that strings come with because we make the assumption of what the string looks like. It's a collection of chars. Okay, so that's another difference, not the one I was fishing for. So there's an important difference that would have directly related to this assignment between strings and arrays. What if I want to change the value at bucket 3 in an array? What do I do? If I want to change the value at position 3 in an array, how do I do that? Yeah, give it a new value. AR at bucket 3 equals whatever, right? Done. What if I want to change the value at bucket 3 in a string? Say this again. How? Okay. Let's go specifically how. That way we can bump into the problem. All right, so we'll start off with the premise that you're wrong. Okay, but it's good that we got the wrong answer. That way we can see what the problem is. So. You couldn't be more wrong. All right, so let's see. Difference between arrays and strings. So if I have if I want to change the value of bucket 3 in an array, for example, if I have in array AR is equal to a new in array with 5 elements in it, something like that. versus a string. So both of those are collections of 5 things, right? In fact, if we want to make these, I can make this a char array, which would make them extremely similar to each other. So both of these guys are collections of chars. All right, and let's go ahead and assume that AR has actual values in it for the moment. Okay, so now, as you pointed out, if I want to change the value of bucket 3 of my array, I would just say AR at bucket 3 is equal to L or something like that. It's changed. Whatever it was before is now overwritten with an L. Okay, so pretend like there's some stuff between these 2 lines where I actually filled the array with something. So now you said, Van, that we can change the value of a string directly. So how would you like me to set the value at bucket 3 in S? Well, to something other than an L, since it's already an L. Like, just leave it alone. It's good as is. All right, so I want to set it to a Q, the letter Q. How would I set the value at bucket 3 in my string to the letter Q? It's a pretty common mistake that beginning programmers are going to make. So how do I set the value at bucket 3 of a string to a letter Q? We're talking about the differences between arrays and strings. I know you didn't wake up because I saw you this morning. You walked past the cafeteria. Yeah, like, do you just have class?
I was here. I went to the bathroom.
Oh, you were already here.
Yeah,
Oh, I don't believe you. No, I still don't believe you. All right, so then answer the question. We've already established that Van was wrong.
Oh,
right. But we're trying to find out why he's wrong. All right, so if you were to attempt to set the value at bucket 3 in a string, we might be inclined to do something like s.char at 3 is equal to a Q. We might be inclined to do something like that, right? Okay. Horrifically wrong. Compiler will hate this. All right, why? What does this guy do? What I've highlighted there. What will that ultimately turn into? This goes back to our argument about things have to, we have to look at what something resolves to.
Wouldn't it be comparing whatever is at the index of 3 to Q?
Okay. Also wrong,
Okay.
but tell me why we're not comparing.
Oh, because it's not a equals operator.
So that's the single equal sign, which is the assignment operator. Double equal sign would be comparing. Okay, so now we'll go back to here. What does that guy actually boil down to? Just what I have highlighted. Forget about the rest of it. Just what I have highlighted there.
Was that part of the answer?
I don't even know what you said. I only listen for wrong answers. So, the right ones are so few and far between. What did you say?
I was guessing that it was finding what was at the index of 3 in the string X.
Okay, yeah. So this would boil down to an L, right? At the end of the day, all this fancy stuff that I have written there would ultimately turn into that, an L. Make sense? So now I'm trying to assign the literal Q into the literal L. I am changing the alphabet, or attempting to change the alphabet. And we can't just do that, right? We can't just like change numbers. Like, I'm not really a big fan of 7. So for now on, that's a 3. And well, we already have a 3. Well, now we have 2 3s. That doesn't work, right? We can't just overwrite literals, right? So even though this guy looked like it might work, when you actually resolve it, this doesn't look like it makes any sense. This is the assignment operator, so assign the value Q into the literal L. We can only assign things into variables, right? And that guy's not a variable, that's a literal. That's a char literal. Okay, so this is how we read the value at bucket 3 of a string. How do we write to bucket 3 of a string? Replace, I think all the versions of replace all occurrences of a certain character with another character. I don't think they let you target an index. Yeah.
Rebuild the string.
Rebuild the string. Short answer is you don't. Okay. You don't. Strings are read only. If you want to change a value of a string, you got to rebuild it. Create a brand new string. Changing, so everything up to bucket 3, leave alone. Change bucket 3 to whatever you want to change it to. Then everything after bucket 3, just copy it across, right? And that should have been some of the challenges you ran into in your assignment. A lot of it was string manipulation, which right off the bat indicates that we are building strings. Okay? When we replace white space with something else, or replace, what was it, exclamation points with periods, what are we doing? We're keeping everything that was not an exclamation point. And as soon as we bump into an exclamation point, we ignore it and put a period in there. Does that make sense? All along, we're building a brand new string. Okay, so strings. So this guy, that doesn't work. So we might say something like, here, we'll just say syntax error. Strings are read-only. Arrays are read-write. It's an important difference between those guys. All right. Arrays we do not have to rebuild to change the value within the array. When would we need to rebuild a array? It seems like it's, how come such a high percentage of these cups leak?
Never get replaced. That's probably my guess.
What you gotta do, look for the clearest ones, because they're the newest, so there's less likely there's a chance for it to crack. That's what I do. I only grab it for like pretty clean.
So you're kind of an elitist when it comes to plastic cups.
I had to be good at something, so I figured, why not plastic cups?
So you've never had a leaky cup since you've implemented this new, I mean, it's kind of like the plastic cup version of racism, is what I'm hearing.
I like those white cups.
So only cups with completely clear complexion you'll work with. Okay, well, I guess to each their own. Something that's so weird to be petty about.
It's not petty, it's just the older ones are usually the foggier ones, or they're cracked ones because they've been through the wash cycle, or they've been used more, whereas the newer ones can be cleaner.
You assume maybe they just took it right out of the container and put it out there. It hasn't even been washed. You might have whatever was in the cardboard shipping package. 20 minutes before that, the thing might have been filled up with those foam peanuts, or are they made of foam? What are they made of? Okay. Disease-ridden. Hey, look, I'm just calling a spade a spade.
Is this the repeat of the smallpox blanket?
This is what happens when you don't wash those clear cups. Well, we want them to be clear the first time we put them out. So my question was, under what circumstances would we have to rebuild an array? So if we want to replace a character at a particular position in a string, we got to build a new string, right? Because strings are read-only. Now, we've advertised here that arrays are read-write, which means that we can just change bucket 3 to whatever we want. Cool. Convenient. But give me a scenario when we would have to rebuild an array. We want more buckets. Yeah, the example we probably used when we introduced them was like if an array is like a house and you decide you want to put a porch on or something like that, you don't just add a porch to an array. You build a brand new house that looks just like the old one that's a little bit bigger so it has a porch, and then you destroy the old house. Pretty inconvenient, right?
When
Okay.
a bigger integer,
Say this again.
when a bigger integer.
Well, yeah, so when you build it, you would use, instead of building it with 5, you build it with 6 or something like that to give you more buckets in there. So if we originally built the array to hold 5 things, and all of a sudden we decide we need to hold 6, we're going to have to build a brand new array capable of holding 6 things, copy the 5 things that are in the original over to the new one, and now we have space for one more thing. All right, so that's the scenario when we'd have to rebuild an array. So arrays are structurally rigid, but they are read-write. Where strings, if we want to add on to a string, we can through concatenation, right? The reality is under the hood, the array is probably being destroyed and rebuilt. So it's probably just as bad, but from a user's perspective, it's like, oh, adding something to a string is easy. Okay. If I want S to be hellos, I would say S is equal to S concatenated with another S. It's not really a word, but whatever. So now that guy's going to be hello with an extra S on the very end of it. Make sense? All right. So those are the differences between arrays and strings, and it's important to keep those apart. And we kind of alluded to this, I don't remember if it was last class or a couple of classes ago. I've referenced things like the linked data structure stuff that we're going to be talking about in 300, the next course. That it's a common misconception that linked lists, for example, are the upgrade to arrays. And that's not a true statement, right? Very rarely in programming languages will you find something that is just a crap tool that only exists to exist. Arrays have their time and place. Linked lists have their time and place. Strings have their time and place. Each one has a feature set associated with them that makes certain problems easier to solve and other problems may be more difficult to solve. Make sense? So with strings, we have our trade-off. The trade-off is they're read-only, so if we want to modify a string, we have to build a new string. But the benefit is strings know how to do a whole lot of stuff to themselves. They have a lot of methods built in. And then on top, and then there's also other objects that operate on strings. And then beyond that, strings are also very malleable. We can add stuff to strings. We can convert them out of string format into something else. So strings are very convenient to work with unless you're trying to change an element in the middle of the string. Okay? Which just happened to be exactly what the homework assignment was. Okay, so let's take a look at this guy. I really should have gotten a clearer cup. All right. Let's just kill those for a second. All right, so I'm going to go ahead and get rid of those two guys. I'm going to gut most of this program. All right, so main is now empty. We'll get rid of show roster, replace player and roster, update, get initial. We'll leave show menu in there and we'll just modify it appropriately for our new menu, right? All right, so brand new program here. We've gone ahead and given ourselves this global variable input for our scanner so that we can use it whenever we need to read stuff in. So we'll use it here inside of show menu. All right, so our menu should be effectively this stuff. I'm just going to copy it out of here. Oop. All right, I think that gives us our new menu, right? Okay. So then when we want to show this menu, because this guy has static in front of it, that means he's owned by the class. We call class methods using the name of the class in which the method was defined. So to initially show our menu, we'll say driver.showMenu, like this. Go ahead and run our program. Here's our new menu. Choose an option. Doesn't matter what I put in. It reads it in. It's going to return it. I'm not using it. So, okay. So now we need to start writing these abilities. So number of non-white space characters is one ability. So let's go ahead and write that method. So we'll say static, and this guy should return the number of something, right? So the number of white space characters should be an integer. So we're going to say static int number of non-white space chars. All right, and this guy will take in a string s as a parameter. We can call a string whatever we want. Let's just take it in as s. All right, and what we're looking for is, now you can treat white space as a lot of different things. Did the assignment dictate what white space was, or are we just treating it as a space? Did it indicate that white space is a whole bunch of different stuff? Okay, so typically, and I'm going to treat it as spaces here, which is fine. A couple of people ask, can you use some of the methods that determine if a character is white space? You can, that's fine. But just more for a trivia type thing, typically, when we talk about white space in computer programming, it's things like spaces, carriage returns, line feeds, anything that's invisible that doesn't take up physical, that could be compressed down. All right, so we could detect for all of those different things. There's a whole bunch of like \n is a line feed, \r is a carriage return. So those are two chars. This would be a char, the char \r. Okay, so even though there's two things in here, that / says, treat the next guy as a command. That's a carriage return, and that guy would be considered white space under most circumstances. We're going to just treat white space as spaces. Okay? So what we want to do is we want to count how many characters are inside of S that are not equal to a space. Right? Now, how many characters are in S to begin with? What's the total number of characters in S? S.length number of characters. Good. Okay, and I want to look at every single one of those characters, right? And I want to count the number of characters that I bump into that are not equal to spaces. So when I want to do something multiple times, and I know exactly how many times I need to do it, in this case I need to do it S.length number of times, what kind of tool should I use? I want to repeat something a fixed number of times. What's the right tool for that job? For loop. Okay, for loop, we're going to repeat something, and they lend themselves to counting problems where we know how many times we need to loop. All right, so we'll do our for loop for spinning through a string. I is less than S.length, I plus plus. All right, so this guy will take I on a voyage between 0 and S.length minus 1, and we're going to use that current value of I to hit each index of S and ask the question if the char at that index is not equal to a space, we want to increment some counter. So we need to keep track of how many non-spaces we bump into. So I need to remember how many non-spaces we bump into. How do we mimic memory in a Java program? How do we remember things in a Java program? Variables. So we're going to say int count. We'll start off at 0, since we found 0 non-space characters so far. Each time through here, we want to investigate the current character we're looking at. How do I get the char at bucket I in my string? What's the tool that we use to look at bucket I inside of a string? Go ahead. Char at. So we're going to say s dot char at I. This guy right here will boil down to the current character that we're looking at in the string. And we want to know if this guy is not equal to a space. If he's not equal to a space, then we want to count him, right? As part of our total count here. So I want to ask a question. How do I ask questions? Conditional, if statement. All right. So we'll say if that value is not equal to a space. If I'm looking at something that is not a space, then count plus plus. After I've gone through the entire string, looking at each bucket and incrementing count every single time I see something that was not a space, I can then return the final value of count. That make sense? Okay. Now, this guy wants a number of non-white space characters, number of words, find text, replace all, shorten. Okay. So we need to read in our string from the user for testing, right? And they probably gave us a nice little prompt for that. Enter a sample text, this guy right here. So we're going to prompt for that guy. So system.out.println. Well, actually, let's do print. Enter our sample text. We'll say string my text is equal to input dot next line, which we'll read in the next string. Actually, wasn't there a next as well? I think for reading in strings, the two of those might not make a difference. All right, so I'll read in our text. Then we'll show the menu. And then based on what the response was, so this is going to be char option is equal to whatever option they chose from that guy. Then I'll ask a question, if option is equal to C. Then we want to go ahead and print the number of non-white space characters. And I think this guy, didn't it kind of give a number of non-white space characters was 181. So what we can do is to keep this guy self-contained, we can decide, let's not make this return an int. Instead, we'll make it return nothing, a void. And instead of returning count, we'll just go ahead and print out the string number of non-white space characters, colon, followed by a space, and then we'll concatenate on the count that we calculated. So this guy will be self-contained, and he will take in the string that we want to count the non-white space characters in. It will do the counting, and then it'll print the result to the screen. Make sense? Okay. Now, when we run our program, we have to ask for some sample text one time, correct? And I think, don't they spit it back out, proving you read it in? You entered.
I think you might need next. I guess we'll see.
So you think this is not going to read in the full string?
I think it's only going to take like the first
Up.
whatever you put in before a space.
That takes in the first word.
Yeah,
Ah,
the first
okay,
word.
gotcha. Yeah, historically I've always used next line. So using next for the other ones works out fine because we're always getting char at 0, right? All right, so this is going to read in my text. Then we're going to say system.out.println you entered concatenated with my text. So we'll read in some text. Well, we'll prompt for some text. We'll read in some text. Then we'll output the text they entered, proving that the text was entered. Now in this program, we only enter the text once, right? And then the menu that allows us to operate on that text, okay. So this stuff happens exactly one time, so we'll leave that alone. Now, this stuff here, where we read in an option and then go through our menu, happens how many times? At least once. We're going to show them the menu one time. They might quit right away, right? So we want to repeat something at least one time. What's the tool that we pull from the toolbox to do that? Do while loop. So we're going to say do all this crap while option not equal to Q. Now notice here that it's screaming that option cannot be resolved to a variable. We defined option inside of this loop. So its scope lived and died here. So what I'm going to do is I'm going to define option up here, and we'll start off as something like a question mark. And then we'll just use option right here. All right, and we didn't need to start it at anything if we didn't want to. We can just create a variable with the understanding that we would be filling it in with a value later. And when we get to this point, we're guaranteed that option has a value because a do loop happens at least one time. Go ahead.
It does say implement quit before implementing other options. So would that be regular?
Implement quit before implementing other options.
It says that in step 2
Continue to prompt. Oh, if they give you a bad input. Valid characters enter, continue to prompt. No, I mean, well, you could. You certainly could. But I think this should work because we're going to have a series of if statements in here that say, if it's C, do this. If it's something else, do this. Keep going as long as it's not equal to Q. So if they did enter something random like a Y, it's going to go through all of our questions. None of them will hit, right? It's also not a Q. It'll just spin back up and ask them again. But it does mean that we can't just have a blanket else inside of our if. So we're going to have if, else if, else if, else if, always checking for the exact options we're looking for, as opposed to just having a catch-all. Oh, you must have entered in this if you didn't enter any of these guys. Okay, so if the option we entered in is equivalent to C, so double equal sign, so we'll read in our option here. If the option was equal to C, then we're going to go ahead and we're going to call driver dot number of non-white space characters, and we'll pass in my text, the string that we wanted to operate on. And this guy should spit out the number of non-white space characters. Make sense? And let's test this dude out. Here's our sample text. Steal that. And number of non-white space characters should give us 181. So there's my sample text. And then we'll say C, and there's my 181. Make sense? So far, so good. All right, number 2, number of words. Okay, so first of all, we need to ask yourself, what's a word? How do we distinguish words from non-words? Go ahead.
It's like the characters where the space separates.
Okay, So the space or spaces separate words, right? So we can walk through our string ignoring spaces, but as soon as we start reading something that's a non-space, so for example, well, here we'll just use one of our menu options as our example here. So if I'm right here and I start reading something like this, N, and I say, oh, that guy's a non-space, so I'm currently looking at a word, still 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 a word. And as soon as I read in this space, if I was currently looking at a word, I can increment my count for number of words by 1. Make sense? And then I reset and say, I'm no longer looking at a word. And I start looking for my next non-space. So now my count is 1. So there might be, if there was 5 spaces in here, I'm going to say, you know, not a word, not a word, not a word. But I've already burned past the I was working on a word and I counted it. Once I count it, I'm going to flip the switch back off that I was not currently working on a word. That way I don't count it more than one time. Hit a non-space, working on a word. Still working on a word. Hit a space, was I working on a word? Yes, increment my count. Turn off the fact that I was working on a word. Hit a non-space, working on a word is true. So on and so forth. And I keep doing that until the end of the string. So I'm going to show you 2 ways of doing this. One's going to be our nice shortcut method. The other way is going to be the logic-based method that we just talked about here. So number of words. So we'll say static void number of words. And this guy will take in a string s as a parameter. And we're going to need a variable that keeps track of whether we're currently working on a word, currently viewing a word. So we're going to make this guy a Boolean. Current word is equal to false, let's say. I'm not currently looking at a word. Then we're going to ask the question. Well, then we're going to also have to keep track of a count. Start that off at 0 for the number of words I find. All right, now I know I'm going to have to go through every single character in my string. So that's going to be our for loop. I is equal to 0. I is less than s dot length, number of characters in s, I plus plus. All right, now in here, I'm going to ask my question. If s dot charat I is equal to a space, if I'm looking at a space and my current word was equal to true, I could say and current word equal to true, or I could just say, actually that's not the right version of true, it's that guy, or I could just say current word. Okay, either one of these will work. I could just say current word. Because current word equal to true is true when, thank you.
I'll give you a card back at lunch.
All right, sounds good. All right, so current word would be equal to true. So if I say current word equal true, if current word was currently true, we're saying true equal true, which is true. So we could just say current word, since it's a Boolean value. So if the current character I'm looking at is a space, which means we potentially just finished working on a word, and we were working on a word, then what do we want to do? We want to set count to be 1 larger than it was. We found a word. Then we're going to set current word equal to false. I've already counted the word I was just working on. Don't accidentally count it twice. Make sense? So we're going to do that if we were looking at a space and current word was true. Else if s dot charat I is not equal to a space. I'm either at the beginning of a word, or I might be somewhere in the middle of the word, so I'll just reinforce the idea that I'm currently working on a word. So if a word has 5 characters in it, I'm going to say current word is true, 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 current word is true. Found a space. Is current word true? Yes. Count plus plus. Now I found one word. Now it's reset because I set current word to false. Then I hit the next guy. Current word is true. Current word is true. Is current word true? Yes. Count plus plus. Set it to false. So on and so forth. And the benefit of that would be this. Let's put a second space here. When I hit the first space, current word is true. I'm looking at a space, so we'll count it. But then we flip it to false. When I read in the second space, I am looking at a space, but current word is not true. Therefore, I will not count it a second time. That make sense? Go ahead.
Are you able to switch the if and if statement? Like, so if the user or if the string is
You mean, are these interchangeable, these two? In this case, yeah, they would be. Yeah, the logic doesn't, that one question doesn't have to be answered before the other ones. They're mutually exclusive. Now, if it's not a space and current word is true, and if it's not equal to a space, the only other option is it's a space, but current word is false. What do I do if it's a space and current word is false? Up here I had 2 spaces. First one, current word would be true, then I set it to false, and I read in the second space. What do I do with that second space? Nothing. I have no logic to perform there, right? I already counted the word we just read. I'm just going to skip this guy. So I don't even need to put logic in. I just need to make sure I don't accidentally count it. That's what this guy is for. And this is why I flip it to false here. Okay? So this is going to go through all the characters in the string. Now after this for loop is done, if current word is equal to true, we need to count it one more time. Does that make sense? Because that means we were working on a word at the very end here. Well, here, let me take that space out. We were working on a word here at the very end, and we never actually hit a space. Instead, we hit the end of the string. Therefore, I have one more word that I was working on, as opposed to this situation where we were working on a word, working on a word, working on a word, hit a space, counted that word, set it to false, then hit the end of the string. Then we should not count an extra word. So after this for loop is done, we want to know, was there one last word we were working on? So if current word, that guy's equal to true, then count plus plus. And then they want our output string to look like oh, they can give us an example of the output string. That's fine. We'll just steal something that looks like this. Number of words is going to be count. All right. So, did they give us an example of what the output should be for that one? Yeah, number of words is 35. So let's see if we got that one right. I need to copy this guy one more time. Let's run this. And then we want to find the number of words, W. And we're, oh, I never actually wrote my if statement in here to handle the W guy. So let's go ahead and write that. Else if option is equal to W, then driver dot number of words my text. Run that again. There's our W, and there's our 35. Make sense? All right. Find text. All these. All right. So let's finish writing this, and then I want to show you. I want to show you a shortcut. Okay, where we can turn all of this logic into 2 lines of code. Okay, so I'll show you a magic trick that's built into the language. So next is find, actually let's do shorten spaces next. Because shorten spaces is going to be relatively similar to what we just worked with, what we were just doing. Okay? Because what we want to do is when we hit a space, we want to know where we left off. Okay? Because if there's 5 spaces, that's fine. We only want to count 1 of them. All right? And it's also going to be another one that's going to be complex the way we're about to write it, but it'll be much easier once I show you this magic trick. So we'll write shorten spaces next. Static void shorten spaces string s. Okay, so this guy, we're effectively looking for words, right? And then we want to keep the first space. All right, so what we're going to do here is we're going to have a Boolean. Let's see. We're going to call this guy kept space. And kept space is going to be equal to false initially, because we have not kept the single space. Then we're going to also have to have our string answer. We're building a new string, as he pointed out earlier. Whenever we make a change to a string, in this case we're shortening the extra spaces in here. Whenever we're doing that, we need to build a brand new string. All right. Now, what if there were spaces before or after? What should we do with that? Are we just compressing spaces between words, or are we getting rid of spaces on either end, or are we limiting it to 1 space on either end? My guess is either one of those answers is reasonable. Okay, do we have a preference? Well, what do we want to have happen? It seems to me white space on either end should probably be ignored. Does that make sense? So let me show you a quick little magic trick for doing that. We have, I'm going to say s is equal to s dot trim. So what trim does is it gets rid of any white space on either end of the string. Now we could have just had our for loop go through and just ignore the white space till we finally hit something. Wouldn't have been the end of the world, right? But this is a nice little shortcut that says, so trim is available in most programming languages, and what it means is get rid of white space before the beginning of a string and get rid of the white space at the end of a string. So we know that the first and last thing in the string is non-white space. It doesn't do anything to spaces in the middle. Make sense? That's the meaning of trim, which would also make a decent quiz question. Also, like I'm building a pool of quiz questions. All right. So now we know after this line that we're definitely dealing with non-spaces to begin with. Could be the empty string, but we're dealing with non-spaces. And we want to shorten our spaces here. So again, we're going to have our loop that goes through every character in the string because we're building an answer string. So this is our standard for int I is equal to 0. I is less than s dot length, the number of characters in s, I plus plus. So this is going to take I on a voyage between bucket 0 and whatever length minus 1 is. Okay? Each time through, If we are looking at a non-space, we want to keep it, right? A non-space just gets tacked on to answer. So if s dot char at I is not equal to a space, that means it's a character or a number or something like it's something real. What am I going to do? I'm going to say answer is equal to answer concatenated with s dot char at I. I'll keep that character. Else, if s dot char at I is equal to a space and we have not previously kept that space, because we're going to keep one. We always keep one space. And we have not previously kept that space. Then we're going to go ahead and say answer. Well, let's just do it this way. Answer is equal to answer concatenated with. We could either just put a space in there if we want, because we know it's a space, or we can say s dot char at I. A little shorthand for this real quick, just to show you. Answer plus equals a space would accomplish the exact same thing. This is our compound operator. So answer plus equals is the same thing as saying answer equals answer plus. So either these two lines effectively are doing concatenation. So pick your poison. They do the same thing. Pick the one that makes the most sense to you. Remember, this isn't a competition of who can write their program in the fewest number of lines. Because you might have somebody who writes their program in 5 lines and it doesn't work, and somebody else who writes their program in 10 lines and it does work, which is the better program. 10 lines, it does work. Plus, especially as a beginning programmer, writing code that you understand is far more important than writing code that you think other people will be impressed with. Okay. Over the years, as you get more and more experience, you will start understanding more efficient, more complex code. All right. Just like when I go out and play basketball now, I usually don't dunk because I don't want other people to feel bad. Right? That's why I don't dunk. That's the reason. Because I'm not comfortable dunking. And even if I could get up that high, I can't imagine what the landing might feel like. Just a lot of bad things. I can just imagine. It would be terrible. Can you dunk? You probably can. You could dunk, right? You probably hit your head on the rim.
Nah, I mean, I could be a couple inches shy if I was standing under from the rim.
Okay.
On a good day, I might be able to hit the net.
I think I can hit the net. I might be able to stand there and hit the net.
Yeah.
I probably can do that one. Now, can you like legit dunk or just like normal, like I can dunk a ball?
Well, I
Like, can you do these like windmill things and stuff like that?
Not that good.
So there was a YouTube video I saw not that long ago where they just had some, basketball exhibition thing, and they picked some random dude from the crowd. He was a little white nerdy guy. You basically didn't expect it, and the guy was like legit. I mean, this dude was like jumping over like 3 people, doing like reverse windmills and stuff. I mean, he must do this like as a a dunk specialist or something like that, like halftime at basketball games or something. He did not look like somebody that could even come close to dunking, and he did way more than just dunk.
I have a friend that's about my height that can dunk.
Yeah.
It's pretty
Well, Spud
impressive.
Webb, yeah, wasn't he like 5'2" or something like that, and he could dunk? That's some ups.
I do not have the ups.
Well, then during the Olympics, there was one of the female long jumpers. I guess she's kind of like the Usain Bolt of her sport or something. They showed, like people were impressed when Michael Jordan could like take off from the free throw line and dunk. And like LeBron James, he takes off 2 steps behind the free throw line so he doesn't bang his belly button on the rim, because the guy's like a physical specimen, right? He's not built like a person. But this long jumper could jump from the 3-point line to the baseline in the air. I mean, at what point is it flying?
Gotta strap some wings on, see what happens.
I was one of those stupid kids that did that. Not the wing thing, but the little blanket. Thought that Superman's cape worked. Does not work that way. I hit every branch on the way down. And that was the only thing that probably kept me out of the hospital. I had all sorts of cuts and stuff, but it was relatively unscathed. I mean, I went to the top of this tree too, so I wanted to make sure I didn't want to hit the house on my forward.
You know if you can control it. Or
Yeah, I mean, the house was like 90 yards away. I was concerned about like ramming into the house. I mean, I just felt I was aerodynamic, and it wasn't even like a legit like a cape. It was like a blanket, and it was one of those that was like knitted, so it had holes all through it.
There was your problem.
That was the problem. You need something with a tight weave. So I'll have to go back out this afternoon and try it again because I'm sure it could work.
Yeah. You only had years to hone this.
Just to hone the confidence. That's right.
Did you go with the full, like the arms up? Or?
Oh, I was committed. Yeah, that was pretty funny actually. I was committed.
Did you do a nice superhero landing?
No. I came crashing to earth. So like my friends were all like, they were laughing actually. But I think that was once they realized that I hadn't like broken my neck. I don't know if they would have cared though. You're like 8 years old, right? 8-year-olds don't care. They'll figure out what happened. And as the parents are trying to explain it to them.
Is that like one of your friends like helping out and that's like kind of laughing to the side?
No, none of them were helping. I'm like peeling myself off the ground crying. Just cuts everywhere. Because it wasn't even like a normal, it was one of those pine trees. We had these giant, they're pines, right? Christmas tree looking things, those are pines?
Well,
Yeah.
Kind of inside you can climb up to the top.
Yeah. Yeah, you have like basically 1 million branches on the way down. I went through all of them.
They urge you to do it, or you just do it
A little bit both.
I don't remember for sure, but I'm guessing I did it on my own. That tree actually has a lot of history because back when like laser tag was like first starting, we had a whole like laser tag set, and my brother once hit up in that tree and he got shot up there and fell down the same tree kind of the same way, except he didn't get hurt. I think it was like almost during winter, so he had like coats on and stuff, and hits the ground. The laser thing's going off like crazy. Flips the switch off and said, "Missed me." My brother's a cheat. The thing is, like, he got hit like, probably 10 times on the way down. And it hit the ground and said, little brothers are cheaters.
I say big brothers are cheaters.
Really?
Yeah.
Why would a big brother have to cheat?
Don't want to be outshone by the youngest brother.
I suppose that's true. All right, what are we doing? Oh, shorten spaces. All right, so we're going to go through every character. I'll get on the laser tag from that. All right, shows shorten spaces. We're going to keep track of whether or not we already kept a space. We'll go ahead and trim the string so we make sure we don't have any spaces at the beginning or the end. Go through every character in our string. If we see a space, or if we see something that's not a space, we're just going to keep it. If we see something that is a space and we had not previously kept that space, we'll go ahead and tack on that single space. Any other spaces that we see in a row, we'll ignore this. Now what we need to do though is after we keep that space, we need to set kept space equal to true to remember that we kept the space. Similarly, as we are reading in normal characters, we need to set kept space equal to false. As I'm reading in a word, I have not kept the space following that word. Make sense? Okay, and if it is a space and we have previously kept it, we're just going to ignore it and move on with life. All right, so then when we're done, does it tell us what our output should look like for that guy? looks like maybe just call it edited, yeah, edited text. So system.out.println edited text is going to be our answer. Okay. Now, technically, we're not returning this. So after we've edited it this one time, our permanent text has not been changed. Are we supposed to change it, or did it not really make it clear whether it had to permanently have a
I don't
change?
think they want to.
Okay. So it wouldn't be hard. We would just return the value here. But all right, so this is for shortened spaces. And shortened spaces is an S. Okay, and did they give us, well, here, let's just say this again. Oh, thank you, my text. And here, we'll just give ourselves a sample thing real quick to test this with. Hello, world, LOL, elephant. So in the end, this should be hello, world, LOL, elephant with single spaces. Oh, that's just showing me what I entered. Now I got to actually do the command. So I want to do S. Hello, world, LOL, elephant. Enough? Okay, and then what's my next menu option? Here, let's do replace all exclamation points. Static void replace all. You know what? Oh, you can't use special symbols. Yeah, that's an interesting one here. Invalid. Oh, because replace all already exists. Okay. Replace all. Nation points. Did I spell that right? All right. Nailed it. So we're going to be building a brand new string. We'll use our for loop that goes through every character in here for int I is equal to 0. I is less than s dot length I plus plus. If s dot char at I is equal to an exclamation point, I want to replace it with a period. Is that the default?
Yeah.
Okay. So then we'll say answer is equal, here we'll say answer plus equals period. Else answer plus equals s dot char at I. So we'll go through every character in our string. If we're looking at an exclamation point, we'll tack on to answer a period, ignoring the exclamation point, replacing it with a period. Otherwise, we'll just keep whatever was in there. So in the end, steal this edited text guy here. After the loop is done, we've gone through every single character. Edited text is inside of answer. All right, and this is for replace exclamation point, which is R. So else if option is equal to R, then driver dot replace all exclamation points. My text. Run this guy again, and let's do hello world LOL, something like that. And then we'll do replace all R period, 3 periods. So we replaced all those guys. All right. So we did this, we did this, we did this, we did this. Now we just need to do find text. And how does find text work? It's going to ask us for the string that we're looking for.
The count of how many times that string occurs.
Ah, okay. So we give it a string, and it's going to find how many times that sequence of characters exists in our string. Okay. Static void find text. This guy will take in a string s as a parameter, and then we'll do a system.out.print. What sequence should I look for? Another dangling preposition. Then we'll say string sequence is equal to input. Actually, it's driver.input. Dot next line. So that'll get our sequence. All right. Then we need to go through our string looking for that sequence, right? See, actually, this is interesting. That'll be the other magic trick I'll have to show you next class will help with this one as well. All right, so what we're doing is when we are walking through our string character by character by character, we are looking for matches on this sequence. Now, what magic tricks do we already have available to us? Do we have index of? Have we seen that with string?
Yep.
Okay, that was in the book? Okay. So what we can do is we can look for the index of this guy. Do we also have substring? Is that in the book?
Yes, they did put substring to that.
Okay, because there's an index of from a certain position as well, I believe. Here, let's just look at this real quick. So we're going to say int pos is equal to let's see, it'll be s dot index of. Yeah, this guy is from index for index of. So so we're going to do something. We'll say int pos. We'll say pos is equal to s dot index of a string. What string? Our sequence. From what index? And we're going to start pos off at 0. From index pos. We're going to keep doing this while pos is not equal to -1. So we'll read into pos the next position of this. We're going to have to keep track of a count. If pos is not equal to -1 count plus plus, then we'll spin down here. Is pos not equal to -1? It's not, because we found a position of it. Spin back up, set pos equal to the next index of sequence in my string starting at position pos, which was the first index. Now, really what we need to say is we need to take a step forward from this guy. So what I'm going to do here, I'll put a little note. Finish this C bug in line 62. Something along those lines. All right, so for your homework assignment, we're going to look in chapter 7, and we want to read, let's do 7.1, 7.2, and 7.3, and be prepared for our quiz on Thursday over those 3 sections. All right, so read 7.1, 7.2, 7.3, and be ready for a quiz. And then we'll finish up this code next class. We'll talk about the string tokenizer trick that I want to introduce to you, and then we'll continue on our discussion about objects. All right, I will see everybody on Thursday. Don't forget, student, faculty, staff Bible study is today at noon. Just go to the cafeteria, sign in for free lunch. God and grub, can't beat that. We usually meet down in the Lakeshore, Landy, the Luptech terrace room, that guy, that room.